Hi everyone, welcome to my channel. So I have to say thanks to one of my friend, uh, Mr. Pulaya, because he also supported me for these classes. After recording the video, he happily supported me uploaded in YouTube. So because he helped me a lot by providing the proper network data. So I am using his Wi-Fi network. So this is my gratitude to my friend Mr. Pulaya also. So thank you Pulaya. Then yesterday means last class we discussed types of chemical reactions. In that, chemical combination, chemical decomposition. In chemical decomposition, two types of chemical decomposition were discussed. One is the thermal decomposition and other one is the photochemical decomposition. In case of thermal decomposition, heat is required, means a chemical decomposition reaction is carried out by heating the thermal decomposition. A chemical decomposition reaction is carried out by sunlight, is also known as photochemical reaction. Both are the chemical decomposition. Let us discuss the one more and important chemical decomposition reaction. Chemical decomposition reaction. For that, so the required materials for the activity, actually have the activity. So let us see the diagram, then we get some idea. So take a beaker or a mug, take a beaker or a mug. So make a holes to the bottom of the mug and insert two carbon electrodes or the graphite electrodes and give a connection to the battery. Give a connection to the battery. Then invert the test tubes on the carbon electrodes. Then fill the mug or the beaker with the water. Add some little amount of sulfuric acid also. Add some amount of sulfuric acid. As you know, sulfuric acid is a good conductor and water also is a good conductor, but to increase the conductivity of water, then its conductivity is increased. So give the connection to the battery. So one is from the positive terminal to one electrode and one is from negative terminal to another electrode. So the electrode which is connected to the positive terminal is called as the anode and the electrode which is connected from the negative terminal is cathode. So in class 8 chemical effects of electric current chapter, so you already know that. So electroplating you have to perform and you have to various types of various liquids to test. They are the good conductors or the poor conductors, and electrolysis of water also. Right? So this is the arrangement. The required materials for the activity: the plastic beaker or a mug. So two carbon electrodes for battery or a cell and connecting wires, water and sulfuric acid, and two test tubes. So then coming to the procedure, take a bottle or take a mug and make fix to the stand and in the inverted position as shown in the figure. Then a rubber cork also we have to use. Fill the glass bottle with 1/3 of the water. 1/3 of the water. Two similar test tube filled with the water, carefully inverted over the two carbon electrodes. See, a mug is taken, small holes are made here, and two electrodes are arranged here. So this is the one electrode and this is the another electrode. Nothing but they are the graphite electrodes. Graphite nothing but carbon. So make a hole to the beaker and insert two carbon electrodes. Fix the two carbon electrodes and give the connection to the battery. Switch off. Then fill the water in that. So this is the complete arrangement. So when we switch on the key, then electricity is passed through the circuit and passed through the electrodes, and the water is a good conductor. To increase the conductivity, we have to add little amount of sulfuric acid to it. So we observed that some gas bubbles are formed near the electrodes. Some gas bubbles are formed near the electrode. Some gas bubbles are formed near the electrode. Gas bubbles are formed near the electrodes. So after that, what happened in this reaction? What happened when electricity is passed through? What happened? If electricity is passed through the acidified water, we can say simply to the water. If dissociate, water divides or decomposes into hydrogen and oxygen. Hydrogen and oxygen. So to balance the chemical equation only, then liquid, gas and gas. So by the passing electricity through the water dissociated into hydrogen and oxygen. Then some gas bubbles are observed in the test tube near the two electrodes, means the anode side and the cathode side. Then we have an idea which is in which electrode hydrogen is liberated, or at which electrode the oxygen is liberated. So carefully remove the inverted test tubes from the beaker and from the electrodes. Very carefully remove these two electrodes from the experiment and bring a burning candle or a burning matchstick. So if we place a burning matchstick near that test tube which is removed from the anode side, and place a burning matchstick at the candle near the mouth of test tube which is removed from the cathode side. So observe carefully. For example, this is a test tube which is removed from the anode, and this is a test tube which is removed from the cathode. When we bring the burning matchstick near the mouth of test tube, if the burning matchstick burns continuously, is a oxygen. When the burning matchstick is put off with the pops out, or burns with the pops out, or burns with the blue flame, it is a hydrogen. So water is decomposed into two gases. One is hydrogen and another one is oxygen. So oxygen is formed near the anode side and hydrogen is formed near the cathode side. And also observe the diagram carefully. So near the cathode side there is a much space. There is more space in the test tube when compared to the test tube which is inverted on the end. So near the cathode the gas occupies the more volume. Near the anode the gas occupies the less volume because of So in this reaction, hydrogen and oxygen is formed in 2:1 ratio. 2:1 ratio. The hydrogen and oxygen is formed 2:1 ratio. 2:1 ratio. So why the hydrogen occupies the more value? Because of it is less weight and less mass than the oxygen. Oxygen has more weight, then occupy the less space, so it has less value, whereas the hydrogen is a less weight and it occupies the more space. So we know the space occupied by a matter we can call as the volume. So near the cathode side where the hydrogen gas is liberated, so we absorb the more space, whereas the oxygen is liberated near the anode, we absorb the less space. So here hydrogen burns in oxygen and water is formed. When the hydrogen combined with the oxygen, so we know that water is formed. Two values of hydrogen. In this reaction, the hydrogen and oxygen form the ratio of volume 2:1 ratio. So the two values of hydrogen and one value of hydroxygen is formed. So now the ratios between the hydrogen and oxygen in water is 2:1 by value. So when electricity is passed to the water, hydrogen and oxygen form 2:1 ratio by its value. So this is called as electrolytic decomposition, or we can call as electrolysis of water. So a chemical decomposition if a chemical decomposition reaction is carried out by electrolysis by electricity is called electrolytic decomposition. Electrolytic decomposition or electrolysis. If a chemical decomposition reaction is carried out or in the presence of electricity, is called as electrolytic decomposition or electrolysis. If the chemical decomposition is carried out by heating, we can call as thermal decomposition. If it is in the presence of electricity, we can call as electrolytic decomposition. If it is carried out in the presence of sunlight, we can call as photochemical decomposition. Observe these either in a thermal decomposition, electrolytic decomposition and photochemical decomposition. In all these decompositions are carried out by absorbing the energy in the presence of energy. Here energy is in the form of heat, light and solar energy. So chemical decomposition by heat, by electricity, by photochemical are also example for endothermic reactions. So yesterday we discussed what is endothermic reaction. Endothermic reaction is a reaction in which heat is required or energy is required to carry a chemical reaction. For a chemical reaction, if energy is required, such reactions are called endothermic reactions. Endothermic reactions. So yesterday we discussed one example is the N2 plus O2 gives rise to 2NO is a N2 plus O2 gives rise to 2NO is a endothermic reaction because heat is required. Then for thermal decomposition means for breaking or for decompose the calcium carbonate or the limestone, heat is energy required. To break down the water into hydrogen and oxygen, electricity is required. And to break down the silver bromide and the silver chloride, for example, AzBr, it dissociates into Ag and Br2, right? So this is carried out by the solar energy. In these examples, energy is required. Such reactions are called as endothermic reactions. Such reactions are called as endothermic reactions. So, chemical decomposition. In a chemical reaction, a single compound decomposes into two or more products. So, example we discussed in previous class, and previously we discussed thermal and photochemical decomposition. Then now we discussed electrolytic decomposition. So in this way, the water is dissociated into hydrogen and oxygen. Such a reaction is called as electrolysis of water. Electrolysis of water. Electrolysis of water. So during this reaction, hydrogen and oxygen ratio is 2:1 by volume. 2:1 by volume. So this is about the electrolysis of water. Now, I hope you understood. Then next one. Third type of chemical reaction. The third type of chemical reaction, chemical displacement. Chemical displacement. Displacement reaction. Already you have an idea about displacement reaction. In class A, highly reactive metal displaces the low reactive metal. Highly reactive metal can be displaces low reactive metal. Displacement reaction. So in a chemical reaction, an element or the group of element or atom is displaced by another one. Such reactions are called as chemical displacement. Right. So those reactions in which one element takes the place of in a chemical reaction, one element takes place by another element or the atom is called. In a chemical reaction, one element takes place by another element, one element displaces by the another element. Such reactions, from where? So in a chemical reaction, from its compound. From its compound is called as displacement reactions. Displacement reactions. So for doing these displacement reactions, take a beaker, dissolve, take water, take some amount of water in a beaker, dissolve copper sulfate crystals, dissolve copper sulfate crystals in a beaker, copper sulfate crystals in a beaker, and it forms copper sulfate aqueous solution. To this copper sulfate aqueous solution, then we add a small piece of zinc or iron. So after some time we observe that there is a change in color happened. So copper sulfate plus iron, the reaction display like this: iron sulfate plus copper. Then one more example, zinc plus copper sulfate. Here zinc sulfate plus copper is. So in a beaker, take two beakers for example. Two beakers you have to dissolve copper sulfate, take copper sulfate aqueous solution. In one beaker you have to add iron, and another beaker you have to add piece of zinc. So observe the reaction what happened. So very well known about these reactions. So copper sulfate, it is aqueous solution, is a solid, and it is also aqueous solution and a solid is formed. And zinc is a solid, it is also aqueous solution, it is also an aqueous solution, and it is a solid. Observe these reactions. In copper sulfate solution is a copper sulfate solution is a compound, copper sulfate is a compound. To this, when we add iron in the copper sulfate solution, after the reaction it forms iron sulfate and copper. So you know very well copper sulfate, which is in blue in color, then after the reaction what will happen? It turns into green solution. So it is blue color solution. After the reaction it turns into green. So here zinc plus copper sulfate, zinc sulfate plus copper. Observe thus in this reaction copper sulfate has copper and sulfate ions. Then the reaction, after the reaction what will happen? We have to iron and sulfate happen. Iron sulfate means here this iron displaces the copper from its copper sulfate solution. So iron sulfate is formed and copper is formed. This copper is deposited on the iron. Then similarly in this reaction zinc displaces the copper from the copper sulfate solution and forms zinc sulfate. So this reaction, these two reactions are the example for displacement reaction, because of in a chemical reaction one element takes place by another element from its compound. So copper sulfate is a compound. In the copper sulfate compound, copper is displaces by the iron in this reaction. So copper sulfate displaces the zinc from in this reaction. So one element is displaces or takes place by another element. So such reactions are called displacement reactions. For example, if you take zinc sulfate plus copper, there is no reaction. Takes place because of, as you know, earlier we learnt about zinc is more reactive than copper. So copper cannot displaces the zinc. Similarly, iron, if you take iron also, iron cannot displaces the zinc because of zinc is more reactive than copper and iron. So generally in displacement reaction, highly reactive element is displaced by a low reactive element. Then coming to the metals, simply you can say that high reactive metal can displace the low reactive metal. Such reactions is also the example for chemical displacement. Chemical displacement reactions. If you take the one more example, lead plus CuCl, copper chloride aqueous solution. If you take lead and it forms lead chloride and copper, lead chloride and copper. So it is a aqueous solution, and here also aqueous solution. It is a solid and it is a solid. In this reaction also copper displaces by the lead. So if here the copper displaces by the lead means the lead has the more reactive. Lead is more reactive than the copper. So such reactions are all takes place. Displacement displacement reaction takes place in these two are iron is more reactive than copper. Zinc is more than copper. In this reaction, no reaction takes place because of copper is less reactive than zinc. Here copper less reactive than lead, so lead displaces the copper. So this type of chemical reaction, is called as chemical displacement. Chemical displacement. Similarly, if we take the one more example, any other example to take, let us take two more examples. Silver nitrate AgNO3 plus copper gives rise to copper nitrate plus silver. It is one of the other one more example for displacement reaction. So AgNO3 it is called as silver nitrate. It is a silver nitrate and copper. This is copper nitrate. And this is silver. Silver colorless solution. This is colorless solution. And when we dissolve, when we drop copper into the silver, so we get blue solution. So it is already you know that it is brown in color, red brown. So after it is forms green color, change in the color. One of the characteristics of chemical reaction, a gas is evolved, a precipitate is formed, and heat is liberated. Sometimes heat required and change in the color. Previous example also blue color copper sulfate solution changes into green. So color change happened. So silver nitrate is colorless. When we drop copper into this, it turns into green. Observe that is it balanced chemical equation or not? So silver, nitrogen only one here, but here two nitrogens are there, not balanced. So to balance that, write this. Now observe that two silver, but react side only one silver. Then write two nitrogens. Okay, two nitrogens. 3 2 just 6. 3 2 just 6 oxygens are said. One copper and one copper. So this is the balanced chemical equation. So colorless silver nitrate. In the colorless silver nitrate, so aqueous solution. Copper, small piece of copper drop in the solution. It forms copper nitrate, which is green color, and silver is deposited. So this is also example for displacement reaction. And one more example, as we know very well, zinc plus hydrochloric acid. So it gives zinc chloride and hydrogen. Zinc chloride and hydrogen is formed. This is also one of the example for displacement reaction. Displacement reaction. Similarly, when so if we take the other example, any other example also. So when iron react with HCl, for example, if the iron reacts with HCl, it forms iron chloride and hydrogen. Iron chloride and hydrogen is also example for displacement reaction. So whenever you observe all these examples, one element is displaced in its compound by the other element. Such reactions are called as the chemical displacement. Such reactions are called chemical displacement reactions. So we completed chemical combination, chemical decomposition and chemical displacement reactions.